In the fifth lecture of probability theory, we introduced several topics that end the first chapter of this module, say the one involving axioms, properties, and theorems of modern probability. We first gave the formal definition of equally likely outcomes by using the notion of simple events. This definition was intuitively given already in the past lectures, when discussing the fairness of random experiments. We then introduced the important concept of conditional probability, given its definition and demonstrating how these remain a proper probability measure. That is, it satisfies Kolmogorov's axioms of modern probability theory We also stated the multiplication rule and gave the definition of independent events. We define what is a partition of the sample space and use this definition to state and prove two very important theorems in probability theory: the law of total probability and the Bayes theorem. The law of total probability turns out to be very useful when we have to compute the probability of an event that can be consequence of other events occurring, like in example 7. The Bayes theorem is very useful when computing probabilities of events that form a partition of the sample space, like in example 8.